Okay, so now we are going to practice of calculating relative molecular mass of some more complex molecules. For example, Na2CO3. As we did it earlier, we're going to apply same procedure here. The first thing, we need to identify the types of elements. So there are three types of elements: sodium, carbon, and oxygen. After identifying, we apply the working definition of relative molecular mass, which states the relative molecular mass of of a molecule is the sum of the relative atomic mass of all the elements or all the atoms present in the molecule. So relative atomic mass of sodium, sum of the relative atomic mass of all the elements or all the atoms. So carbon plus ArO. After identifying like the type of element, the second step comes the number of atoms of each element present in the molecule. And as I told you before also, it is presented by the subscript of the symbol of an element in the formula. For example, Na, the subscript is 2. So 2 is the number of atoms of sodium. Carbon is none, so it means it's 1, and oxygen shows 3. And then we are going to write that number in front of the atomic mass. So it's 2 sodium, it's carbon is 1, so no need to write, and oxygen is 3. And then we write the atomic masses. Sodium is 23, carbon is like 1 times 12 plus 3 times 16, so 46 plus 12 plus 48. So 8, 2, 10, 6, 16, carry 1, 4, 4, 8, 9, and 10, so 106. So relative molecular mass of Na2CO3, mrNA2CO3 will be 106, and molecular mass will be 106 gram per mole. Now there are some molecules who has water molecules in it. We call them crystals, or we can say ionic crystals. Ionic crystals are the crystalline molecules having water molecules in it. Crystalline molecules having water molecules in them. For example, copper sulfate crystals, CuSO4.5H2O, copper sulfate crystals. Now here one thing you need to remember. These are copper sulfate crystals, and then we have CuSO4. This is also copper sulfate, but this is a powder form, not crystal. We'll say copper sulfate. We don't say crystals here. Neither we say powder nor we say crystals. Now, if there is water molecule present in the molecule, like CuSO4.5H2O, we call them copper sulfate crystals, or we call them crystalline molecule. Or we also say, or we also call them hydrated molecules. When there are no water molecules in the formula, we call them anhydrous molecules. So hydrated molecules and anhydrous molecules. Now, how to calculate the molecular mass or relative molecular mass of hydrated and or anhydrated molecules? So we do copper sulfate like here, CuSO4.5H2O, and on another side CuSO4. We apply the working definition, and as per the working definition, what we are going to do, we are going to do MR. Number one, we are going to write the atomic mass, copper plus Ar sulfur plus Ar oxygen, and then we are going to write the number of atoms of each element. Copper is 1, sulfur is 1, oxygen is 4. And just to remind you here, in the formula it's CuSO4.5H2O, or you can say CuSO4 5H2O. It doesn't mean that we are going to multiply 5 H2O molecules. No. We are going to add them. And how many? 5 H2O. And then we are going to apply same principle here. We are going to say Ar copper plus Ar sulfur plus 4 Ar oxygen plus 5 inside 2 ArH plus Ar oxygen. You can open the bracket, multiply and put it together. Instead of doing it, I'm just going to put the atomic masses here and going to add them together. So copper is 63.5, sulfur is 32. You don't need to remember them because you're going to get data book with the paper. So you'll get data book with the paper, and you can use data book. There will be a periodic table in data book. If you are in IGCSE, then you'll get a periodic table with the question paper. If it's a multiple choice question paper 1 or question paper 2 for extended, then also within the question, if there is no periodic table given, then within the question you'll get the atomic mass of each element. Okay, so it's like 4 times oxygen 16 plus 5, 2 times 1 plus 16. So it's 63.5 plus 32 plus 64 plus 5 times 18. Now we are going to use the calculator. So let me find the calculator. Let me close this. I think I opened a wrong calculator here. Yeah, this one is the original one. Yeah, so I have 63.5 plus 32 plus 64 plus in bracket I'm going to use okay, so first let me do this one and then plus. So this is for this one without water. This is for this one without water. So this is the MR of CuSO4, which is 159.5. This is without water. And then remember, 5 times 18, 90 plus 159.5. So this comes 249.5. So 249.5. This is 249.5. So this is the one for anhydrous, and this is for hydrate molecule or hydrated molecule, or you can say crystals. So crystals molecular mass is always bigger than the anhydrous molecules. Okay, so just to remind you once more, the hydrated molecules or the crystalline molecules, they have H2O in it. That doesn't mean that you're going to multiply. No, you're going to add the molecular mass of water present in the molecule. Okay, just remember this. If you have questions, message me again. Thanks.